Okay. So if I'm talking here that what is metals, okay? Because in this chapter, we're going to study about the properties of metals and non-metals, okay? And then we're going to discuss them in detail. So you know that elements has been broadly classified into three broad categories. One is metal, another one is non-metal or metalloid, and the third one is okay, metalloid, and okay, and the last one is non-metal. So you know that what are metals first? According to the, if I'm talking here is that what are metals? So metals are those elements that are going to have one or two or three electron in their outermost shells. Okay. What are metals? Metals are those elements that are going to have, you know, that elements are going to have electrons in their outermost shell. Like for example, if I'm talking the magnesium. Magnesium has atomic number 12. Its electronic configuration is 282. Got it? 282. So if it is 282, okay. So it means that 282 means the outermost shell's electrons are 2 in this one. Like for example, atomic number 17, 287. Okay. Hydrogen
Yes,
has 1 electron, atomic number 1. So electronic configuration 1. Helium, atomic number 2. Other elements except the hydrogen and helium, except the hydrogen and helium, which are not metal, which are not metals. Okay, and they have 1 and 2 electron in their outer motion. Other element, if they are having 1 or 2 or 3 electron in their outer motion, they will be considered as they will be considered
no,
as metals. And if they are having 4, 5, 6, and 7 electron in their outermost shell, they will be considered as non-metals. Understood?
yes,
What
yes,
are
sir.
metals? Metals are those elements that are going to have 1 or 2 or 3 electron in their outermost shells. Okay. And since they have 1 or 2 or 3 electron in their outermost shell, so they generally lose electrons. They generally lose electrons. For example, if
Okay.
I'm having 2, 8, 2 electronic configurations, and the nearest noble gas for this one is neon, that is 2, 8 electronic configuration. So this is magnesium. So what did magnesium will do? Magnesium will lose 2 of its electron in order to, and will become Mg2 positive, 2, 8 electronic configuration. So why it is becoming 2, 8? In order to attain stable electronic configuration to the nearest noble gas. In order to attain stable electronic configuration, okay, in order to attain stable electronic configuration to the nearest noble gas. Okay, that's why metal generally lose electrons, and when some element lose electron, they will acquire a positive charge. They will acquire a positive charge, and charged particles are called ions. There are two types of ions. One is cation, another one is anion. Anions are negatively charged and cations are positively charged. They are positively charged. Understood?
Yes, sir.
So stable electronic configurations, elements in metal generally lose the electron in order to attain a stable electronic configuration to the nearest noble gas. Okay. So if I'm
Yes,
having two, like for example, oxygen, 2,6 electronic configuration, 2,6
yes.
electronic configuration. So what oxygen will do?
It will gain two.
It will gain 2 electrons. So non-metal generally gain electrons. Non-metal
Yes,
generally gains electron. Okay, in order to attain stable electronic configuration. So it will gain. So when oxygen acquire 2 negative charge will be given O minus 2. Got it?
yes, sir.
So you have to do like this way. Okay, so note it down that elements first learn it, then you have to note it down.
Yes, sir.
First learn it that these elements are generally the metals means these elements that generally those elements that generally have 1 or 2 or 3 electron in their outermost shells, except the hydrogen and helium. Hydrogen has 1 electron in its outermost shell and helium has 2. They are not non-metal, so there is an exception for them. They lose electrons and become electropositive ion that we call cations. They have low ionization energy, means they can easily lose electron. So ionization energy means they can easily become ions by losing electron easily. Okay, metalloids show the
Yeah.
property of both metals and non-metals. About the non-metal, they generally have 4 to 7 electrons in their outermost shell. Okay, they generally gain electrons and form electronegative ions. They have low electron gain enthalpy. Okay,
Yes, sir.
note it down without seeing. First, learn it. First, learn it.
So what's enthalpy?
What is
Enthalpy.
enthalpy? Is energy. Enthalpy is energy.
Yes.
Learn.
Yes, sir.
Okay, speak. Speak.
Metals. They generally have one or two or three electrons in their outermost shell, except hydrogen and helium.
Okay, next.
And metalloids, they show properties of both metals and non-metals.
Okay,
And in non-metals, they have more than they have usually they have 4 to 7 electrons in their outermost shell.
next.
Metals usually lose electrons and their electron positive cations.
And they form
And non
electropositive ions called cations.
Yes, sir.
Next.
And non-metals, they usually gain electrons, and they and electronegative ion known as anion.
Okay, next.
Metals have low ionization, low ioniz metals have low ionization enthalpy,
Okay.
and non-metals have low electron gain enthalpy.
Low electron
Gain.
gain enthalpy.
Yes, sir.
Okay. Note it down by your own.
Done, sir.
Now, what is enthalpy? It is the amount of energy that is being required to remove ionization energy. What is ionization energy? It is the amount of energy that is being required to remove an electron from the outermost shell of an isolated gaseous atom. This is called ionization energy. Okay, and ionization energy is always positive. Means when we are going to remove an electron from any atom, whether it is a metal or a non-metal, if you are removing, you have to give the energy to it. Okay. So we'll say that it is the amount of energy required to remove the outermost shell of an isolated gaseous atom. Okay. Got
Yes,
it?
sir. Yes, sir.
And it is always positive. It is an endothermic process always. Okay. It is an
Yes, sir.
endothermic process.
Endothermic.
Yeah. So note it down. First memorize it, then you have to note it down. First memorize it. Memorize it fast. Amount of energy required to remove an electron from the isolated gaseous atom. Means, first of all, if you need to separate the electron from the sodium, you want to remove. So first of all, you have to convert sodium into gas. Whatever the energy you require to melt it, it is not considered to be as ionization energy. Now, when you have gaseous sodium, then you have to remove an electron from it. That is called ionization energy. Okay, and it is always positive, means it is an always endothermic process.
Done, sir.
Okay, note it down.
Done, sir.
Done?
Yes, sir.
Okay. And it is always, how it is? It is always positive. Okay.
Endothermic.
Now, moving towards the next part is that if I'm talking about the physical properties of metals, okay. So metals are Okay. Metals generally have high densities. Metals generally have high densities, approximate 22.5 gram per centimeter cube. Okay. And lithium has the lowest. Lithium has the lowest density, that is 0.5 gram per centimeter cube. So metals generally have high densities. Metals generally have
High density.
high densities. While non-metals have low density. They are generally gaseous. Okay. So if I'm talking about the
Yes.
metals, so metals have high densities. The highest density is of 22.5 gram per centimeter cube. Means, for example, you have a ludo dice, approximately ludo dice. So that if we imagine that its dimension, length, breadth, and height is of the dice is 1 centimeter. So that cube is going to weigh 22.5 gram if it is made up of iridium, and the same cube dice, if it is made up of lithium, then it is only going to weigh 0.5 grams. So, and they generally have very high melting and boiling points. The tungsten has the highest melting and boiling point. Tungsten has the highest
High. Mhm.
melting points. Okay, and there are some other metals, that is gallium and cesium, that has low melting point. They are so soft that even if you kept it on, sorry, if their melting point is near body temperature. So if you kept it on the your palm, it will start getting melted. Gallium and cesium are the two metals that have melting point near room temperature. Melt when kept on palm. Generally, metals are solid, but mercury is liquid at room temperature. But mercury is liquid at room temperature. Okay. What
Yes,
is it?
sir.
Mercury is liquid at room temperature. Understood?
Yes, sir.
Now, generally solids, metals are generally solid, but mercury is liquid at room temperature, shiny, malleable, and can be drawn into thin sheet. Okay, ductile. We can simply say here that they are hard, but alkali metals like sodium and potassium are so soft that they can be even cut with the help of knife. Understood?
Yes, sir.
They can be easily cut with the help of knife. So note it, write, revise it and learn it, each and everything that metals have high densities. Okay, these are the exceptions that are going to ask in your examinations. That malleables are ductile, which is the most malleable metal. Malleability means that it can be drawn into thin sheet, and ductility means that it can be drawn into thin wire. Okay,
Yes, sir.
gold is the most malleable and ductile metal. Okay,
Yes, sir.
they are very hard, but some metals are so soft that even they can be cut with the help of knife, and they are sodium and potassium. Okay, which we call them alkali metals. Understood?
Yes, sir.
Learn it fast.
Sir, gallium and which metal has low melting point?
Gallium is
Gallium and which metal has low melting point?
gallium and cesium are the two metals that they are so soft that they can even melt on the when you cap it on the palm.
Yes.
Done. Done. Shazil. I'm saying you done. You start noting.
Yes, sir.
Noted. You done?
No, sir.
Noted fast.
Sir,
Yes.
ductile means they can be drawn to thin wire, right?
Ductile means?
They can be drawn to thin wire sheet.
Yes, they can be drawn into thin sheet, wire, not sheet.
And malleable.
Malleable means they can be drawn into thin sheet.
Okay. Done, sir.
Done.
Yes, sir.
Uh, Next, for the non-metals, if I'm talking here, okay, non-metals are generally opposite to the metals. For example, metals conduct electricity, non-metal do not conduct electricity. Metals are sonorous, metals are not sonorous. Non-metals are, we can say that non-metals are good conductor of electric, like non-metals are generally solid or gas. They don't exist. There is only one non-metal that exists in the liquid state, that we call it bromine. Okay, so there are some exceptions that generally comes for the non-metal. The exception of non-metals are they are generally solid, but bromine is the only non-metal that is liquid at room temperature. Bromine is the only non-metal that is liquid at room temperature. They are generally bad conductor of heat and electricity. Okay, but except graphite, which is an allotrope of carbon. Allotrope, let me explain you that they are due to different arrangements. Like when carbon atoms are arranged in hexagonal arrays like this. Okay, in hexagonal arrays like this. Okay, then they form, they form, they are considered to be as we call them simply. This is hexagonal structure of graphite. Gonal structure of graphite. Okay, this will study in detail in the other chapters. Okay, so graphite is the in graphite we can simply say that uh graphite. Okay, they are the good conductor of we can say that they are good conductor of electricity. Why? Because you see here that this is one carbon. Okay, and this
Yes.
carbon is attached with three other carbon, but carbon make generally four bonds, so its one electron is free, and this make it graphite in good conductor of electricity. But in diamond, carbons are arranged in another structure that is called tetrahedral structure, which make it hard and rigid and dense. Why it make it so hard? We'll discuss in the next in the next chapter. So this is the structure of diamond, that in which the carbons are arranged in different patterns, and that's why diamond in this every carbon atom is bonded with four other carbon atoms. Okay, they are bonded with four other carbon atoms. So none of the carbon atoms is free. Okay, so all electrons are participating in the bonding. So no, there is no free electron. No free electron means bad conductor. So diamond is bad conductor but good conductor of heat. Similarly, if I'm talking here, is that okay, bromine is the only non-metal that is liquid at room temperature. Okay, bad conductor of heat and electricity, except graphite. All we can simply say that except the graphite, like graphite is a drop of carbon, which is good conductor of electricity. They are shiny. Shiny non-metals is mean they are generally dull in appearance, but shiny non-metal is iodine, and diamond is also shiny. It is an drop of carbon. Brittle means they can be easily broken into when you means when you hammer it, a non-metal generally break. But diamond, because of its special structure, tetrahedral structure, diamond is so hard and rigid that it is the naturally occurring hardest substance. Okay, so diamond is very hard. You cannot break it generally by hammering it. Okay, so start doing. No means first memorize it, then you have to write it down. Memorized?
What 1 minute, sir. Sir, what is allotroph mean?
What are you saying?
Allotroph. Sir,
Done.
allotroph mean.
Electrophilic. Allotrop.
A-
Allotrop means that if an element or a substance exists in different forms in nature, we consider it as allotrop of carbon. Okay, note it
Yes,
down.
sir.
Allotrop means any like for example, the same element carbon exists in the form of graphite, and same element carbon is existing in the form of coal. Same element carbon is existing in nature in the form of diamond. They all are carbon, but due to different arrangements of carbon, like here the pattern is hexagonal structure in graphite, but in diamond it is tetrahedral structure like this. So because of this, their physical properties like melting point, electrical conductivity are changed. Okay.
Yes, sir. I'm done, sir.
We done?
Yes, sir.
Okay, start writing. Done? Start writing,
No,
wait.
sir. Yes, sir.
Start writing. And your image is locked. Okay.
Done, sir.
Uh, Check whether you have committed some mistake or not.
Done, sir.
So let's discuss the questions over this topic. Just a minute. Yes, Shazil, what could be the answer for these questions? Question number. Question number 30. What should be the answer for question number 30? Question number 30.
Yes, sir. Sir, 2 comma 8 is neon, right?
Yes, yeah.